Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will start discussing section 2.3. It's about indices and logarithm. Let's have a look at the objectives of this section. By the end of this section, you will be able to evaluate b to the power n in the case where n is positive, negative, a whole number, or fraction. Simplify algebraic expression using the rules of indices. Evaluate logarithms in simple cases. Use the rules of logarithms to solve occasions in which the unknown occurs as a power. Our presentation today will focus on the first objective, which is evaluate b to the power n in the case where n is positive, negative, or fraction. Let's go. Now, this is index notation. If I have b times b, this is b times b. B is multiplied by itself 2 times, so this is b squared. Why? Because I multiply b times b 2 times. Okay, now what if I have b cubed? Now b cubed, it is b times b times b. b, b, b. Why? b is multiplied by itself 3 times. That's why we write it b to the power 3. Now, if I have b to the power b times b times b, it can be written in the form of b to the power 4 because b is multiplied by itself 4 times. Now, if I have b times b times b times b times b nth times, okay, then it can be written as b to the power n. So if I multiply b by itself 5 times, it is b to the power 5. If I multiply b by itself 10 times, it is b to the power 10. So a total of n b's multiplied together. Now, in general, if I have m equals b to the power n, m equals to the power n, then we can call b the base from which we have b. So this is called the base, and this is called index, power, exponent. Okay, so n is the power, n is the exponent, n is the index, and b is the base. Now we say that b to the power n is the exponential form of m to the base b. So b to the power n, it is the exponential form of m to the base b. Now if n is negative, this is the first case actually. Let's say it is the first special case. When n is negative, then b to the power minus n equals b to the power minus n equals 1 over b to the power n. b to the power minus n equals 1 over b to the power minus n. Well, suppose that I have b to the power n minus n equals 1. What's happened? Well, it looks like that I shifted minus n, the power, minus n. Now it goes down and it is now plus n. So b to the power minus n, the whole number has been shifted or moved from numerator to denominator, from up to down, but we change the sign of the indices. So b to the power minus n equals 1 over b to the power plus n. Okay, let's continue. And we have also another definition or another rule, call it rule. If you have b to the power 0, it equals to 1. Anything raised to the power 0 equals to 1. Suppose that I have 100 to the power 0, not 100, let's say 1,000. 100,000 to the power 0, it equals to 1. So anything raised to the power 0 equals 1, except of course 0 to the power 0 does not equal to 1. 0 to the power 0 does not equal to 1. It is 0. So anything raised to the power 0 equals to 1. So let's say that if I have b to the power minus n, this is 1 over b to the power n, and b to the power 0, it equals to 1. Now, Let's have some examples. When I have 3 squared, this is 3 times 3, so it is 9. 4 cubed, this is 4 times 4 times 4. Okay, this is 4 times 4 times 4, and it does not equal to 4 times 3. Okay, this is one of the common mistakes or popular mistakes that students usually have in their solution. So 4 to the power 3, it's not 4 times 3, it is 4 times 4 times 4, so it is 64. Okay, and 7 to the power 0, of course, it equals to 1. Okay, let's go. Just erase this. Now, let's have this definition. What if I have half 9 to the power half? We know that 9 to the power half, it is square root of 9. Actually, there is a hidden number here. It is 2. So we call this the second root of 9, or square root of 9 equals to 3. Okay, so square root of 9 equals to 3. Why do I have here square? Because I have here at the denominator 2. Okay, what if I have a to the power 1/3? So I have 3 here at the denominator. So this is, as you see, cube root of 8. So 9 to the power 9, 9 to the power half, it is square root of 9. Okay, 8 to the power 1/3, it is third root of 8. Now, if I have 625 to the power 1/4, it is fourth root of 625. What if I have, let's say, 32 to the power 1/5? Now it equals to the fifth root of 32. Okay, so what if I have nth root? I'm going to write it here, n to the power 1/2. Oh, I'm sorry, that I have b to the power 1 over n. I'm going to erase this and erase this. Okay, what if I have b to the power 1 over n? Then it can be written in the form of nth root at the power, or at the nth root of b, nth root of b. Okay, so if I have b to the power 1 over n, it equals to nth root of b, nth root of b. Now, how can I calculate 625 to the power 1/4? We said it is fourth root of 625. How can I calculate fourth root of 625 by using calculator? I want to calculate fourth root of 625 by using calculator. Now, this is the question: how to calculate 625 at the power of 1 over 4 by using calculator. It's very simple. If you have your calculator, you can follow us. Please bring your calculator and try to follow the following procedure in order to calculate fourth root of 625. First, 4, then shift 4, then shift, then you press this button, number 3, then you type 624, then equal, and what is the answer? The answer is 5. So fourth root of 625, it is 4, then shift, then this button, 625 equals to 5. If it is a to the power 1/3, say this is a to the power 1/3, and I want to find out this is cube root of 8, it will be 3, then after that shift, then this button, then 8 equals, and finally it will be 2. Okay, so this is how you calculate and find out the nth root of any number. Nth root of any number. Okay, let's continue. Now, assume that the exponent is not integer. It's neither positive integer nor a negative integer. It is not integer, it's a fraction. And it takes the form p over q. This is the power, the exponent, the index. So if I have the power p over q for some whole numbers p and q, we define if I have p to the power p over q, this is a qth root of p to the power p. Or if you want to take it p to the power m over n in some textbook, you can find it. This is nth root of p to the power m. Now, just have a look at this occasion. B to the power p over q equals qth root of p to the power p. Now, the power here is fraction, numerator and denominator, up and down. Now, see the number which is located down at the denominator, it will be the index of the radical sign. The index of the radical sign. But the number which is up at the numerator, it becomes the power under the radical sign. So, which is down, it will be outside the radical sign. And the number which is up, it will be inside the radical sign and it will be the power. Okay, so suppose that I have, for example, I have 120 to the power 3 over 5. Now, it can be written as fifth root, fifth because 5 is down, fifth root of 120 to the power 3. Okay, this is how we can apply this occasion. Let me just erase everything here. So b to the power n, here b to the power p over q equals qth root of p to the power n. Now this means that p to the power p over q is a number which when raised to the power q reduced p to the power p. So b, again, this is very good expression here. P to the power p over q to the power of q, then you can cancel q with q, then it is p to the power p. Okay, now let's go and continue using this definition. If I have 16 over 3, 33 over 4, as you see, this is 4th root of 16 to the power 3, which is equals to 8. Now 8 to the power 2 over 3, it is now 3 at the denominator, so it will be the index. So it will be 3rd root of 8 squared, and here it is 25 to the power minus 3 over 2. This is the 2nd root of 25 to the power minus 3, and finally it gives 125. Okay. Now, again, how to calculate 25 to the power minus 3 over 2 by using calculator. First, type 25, then press on this button. Number 2, number 3, open a bracket. Number 4, the minus sign. Number 5, type 3, then divide. Number 6, number 7, type 2, and then close the bracket. Number 8, and then type equal. You will get 125, or 8 to the power 8 to the power minus 3, which is the same answer as 125. Okay. Now let's go to some rules of indices. Well, this is the set which explains the rules of indices. Now, rule number 1, if I have p to the power m multiplied by p to the power n, this is multiplication. The rule is in case of multiplication, the power will be added. So multiplication becomes addition. So p to the power m times p to the power n, this is p to the power m times n. Suppose that I have 2 to the power 4 multiplied by 2 to the power 6. Then Based on this rule, this is 2 to the power 10. Why? Because 4 plus 6, it is 10. Now, the case of division, b to the power m divided by b to the power n. Now, my division becomes subtraction. Again, if I have 5 to the power 4 divided by 5 to the power 2, so this is 5 to the power 4 minus 2, which is 5 to the power 2. Now, I said multiplication becomes addition. Here, addition. Division becomes subtraction. Now, what if I have p to the power rule number 3? This is rule number 3. p to the power m to the power n. M to the power. This is power to the power. Now, in case of power to the power, this is multiplication. Okay? Case of p to the power to the power, it becomes multiplication. Here, the operation is multiplication. You can write it as p to the power m times n. Okay? So this is multiplication. So power to the power, it is multiplication. Now you can use this. It's not a rule. It is one characteristics of brackets. Now a times b, it's distribution. You are distributing n on every term inside the bracket. So when you have a times b to the power n, so n will be given to a as well as to b. So a times b to the power n, it equals to a to the power n, b to the power n. Suppose that I have, for example, 5 times 2 to the power 2, then it equals to 5 square. I'm going to give square to 5, multiply by also, I'm going to give it to 2. So as you see, 2 has been given to 5 and given also to 2. So it will be 5 square times 2 square. 5 square, it is 25, multiplied by 2 square, 4. So the answer equals to 100. And I know that 5 times 2 is 10 to the power 2 equals to 100. Okay, so this is rule number 4. So rule number 1, addition becomes multiplication becomes addition, and rule number 2, division becomes subtraction. Rule number 3, power to the power becomes multiplication, and if you have bracket raised to the power n, so this n will be distributed on every term inside the bracket. By the way, we are using this in case of multiplication, but it is also true in case of division. I mean, if you have a over b to the power n, then it is also a to the power n divided by b to the power n. Okay, so you can use it in case of multiplication as well as division. Well, 2 to the power 2 times 2 to the power 5, this is multiplication. Multiplication becomes addition. So it will be 2 to the power 2 plus 5, which is 2 to the power 7. Number B, 4 to the power 6 divided by 4 to the power 2. Division becomes subtraction. So it will be 4 to the power 6 minus 2. So it's 4 to the power 4. Number 3, 10 to the power 2 to the power 3. This is number 3. So this is power to the power. It becomes multiplication. 10 to the power 2 times 3. So it is 10 to the power 6. And finally, 2 times 3 all to the power 4. You will be given 4 to 2 as well as to 3. So it will be 2 to the power 4 multiplied by 3 to the power 4. So finally, you will have the answer of this expression. This is a practice problem, and I expect all of you try to solve these problems. This is simplified by using rules of indices. Now I'm going to solve 3 more problems as practice. If I have 3a to the power 4 all to the power 3, I'm going to give the power 3 to the number 3 as well as to a to the power 4. So it will be 3 to the power 3, as you see, a to the power 3 to the power 3. Now 3 to the power 3, it becomes, or it turns to 27, and 4 a to the power 4 to the power 3, it becomes a to the power 4 times 3. Why? Because this is power to the power. So a to the power 4 times 3 here, it gives you 12, a to the power 12. Second,